Okay guys, welcome back to my YouTube channel. Please and please you guys should do so well to subscribe to this channel. Please, you can hit the subscribe button and the notification button so you can get notified anytime I upload a new video. Thank you very much. So today we are going to be looking at implicit solutions to differential equations. So here we are having a simple question on to show that y minus c raised to power 2 is equal to cx is an implicit solution to 4x times y prime raised to power 2 plus 2x times y prime minus y equals 0. So to go about the solution to this problem, we are going to evaluate this particular expression implicitly to show that it is equal to 0. So how do we do that? Solution. We are given y minus c raised to power 2, which is equal to cx, right? And we also show that this, when simplified implicitly, evaluating this, we'll use it to evaluate this and it will give us what? 0. So how do we do that? Now we simplify it implicitly. So simplifying implicitly, we have 2 differentiating this, right? 2 comes here, that's 2 open brackets y minus c, right, raised to power 1, then times dy dx, which is equal to, differentiating this, we have c, right? Differentiating this with respect to x, we have what? C. So since dy dx, which is equals to y prime, right? So replacing this with y prime, we have 2 open brackets y minus c times y prime equals c. Now making y prime subject of formula, we have y prime is equal to c open bracket 2 open bracket y minus c. Now we're going to be substituting this equation into this expression. Now when we successfully substitute this equation into this expression, then we have successfully shown that this equation is an implicit solution to this. So substituting this into this, we have, now given the equation is giving us 4x. Now this is y prime raised to power 2, so we replace this with y prime, which we have times c raised to power 2 times y minus c raised to power 2, right, plus 2x times, now we have here to be y prime, right? So replacing this, we have c open bracket 2 times y minus c minus y equals 0, right? Now I want to evaluate this. So rewriting this, we have 4x times c squared raised to power 4 open bracket y minus c raised to power 2, right, plus 2x times c open bracket 2 bracket y minus c. Now 2 cancel 2 and 4 cancel 4, right? Then we have minus y equals 0. Now I can choose to multiply through by y minus c raised to power 2. So multiplying through by y minus c raised to power 2, we have y minus c raised to power 2 times xc squared divided by y minus c raised to power 2 plus y minus c raised to power 2 times xc raised to power y minus c, then minus y minus c raised to power 2 times y equals 0. Then this will cancel out this, and this will cancel out one of these. Then we are left with x times c squared plus y minus c times xc minus y minus c raised to power 2 times y equals 0. Then evaluating this, we have xc squared plus xc times y, this is y xc minus xc times c, this is xc squared minus y minus c squared times y equals 0. So we see that this will cancel out this, but this can't cancel out anything here. So we can say, since y minus c raised to power 2 is given to us as cx, right? They give us y minus c raised to power 2 to be equal to cx. Then we can say that replacing y minus c raised to power 2 with cx, y minus c raised to power 2 with cx, replacing y minus c raised to power 2 with what? Cx. We have, then this has already cancelled out. We have yxc minus cx times y equals 0. So multiplying this by this will cancel out. We have what? Equal to 0. So we have successfully shown that the factors, or this variable, or this equation here, we have successfully evaluated it implicitly and shown that putting it in this particular equation, we have it to be equal to 0. So thank you guys for watching. Please and please subscribe.